This video will focus on understanding the three different ways to give compass directions and how to draw diagrams to represent a given description. The second video, 7b, will apply these concepts and skills to solve simple word problems using right triangle trigonometry. Let's begin by looking at a basic directional magnetic compass. A magnetic compass works by aligning a floating magnetic needle with magnetic north, allowing people to navigate in their chosen direction. We won't get into the geographical and technical differences between true north and magnetic north, other than saying that true north points to a fixed point on the Earth's surface, the geographic North Pole, whereas magnetic north relies on the Earth's magnetic field, which is constantly changing over time. In fact, when compasses became common, it was quite quickly realised that they didn't always point to true north. The difference is known as the magnetic declination, but we won't expect you to take them into consideration in your maths problems, because each problem would reference one or the other, not a combination of the two, so the mathematics will be the same. Keep in mind also that real-life problems, especially over large distances, would need to take into account the curvature of the Earth as well, using arcs and spherical triangles rather than straight lines and flat, plane shapes. Magnetic compasses have been in use in Europe since at least the 12th century, and even longer in China. Before the compass was invented, sailors relied on the sun and stars and known landmarks to help navigate the Earth. The layout of a basic compass face is often referred to as a compass rose or a compass star. The compass rose shows the four main directions, north, south, east and west, known as the cardinal compass points or directions, with north-south considered the major cardinal axis. The directions halfway between these cardinal points are known as the ordinal points. These directions are named by combining the two cardinal points with north or south stated first, giving us northeast, southeast, southwest and northwest. Some compass roses are further divided in half again, creating interordinal points. Again, they are named using the cardinal point first to indicate from which direction we are halving the ordinal point. North-northeast means north of northeast, telling us we are halfway between the north and the northeast. Completing this extended rose, we also have east-northeast, east-southeast, south-southeast, south-southwest, west-southwest, west-northwest, and north-northwest. Starting with a full revolution of 360 degrees, we can easily determine all the angles simply by halving. First, from north to south must be 180 degrees, being halfway around the full 360 degrees. Similarly, this is true between east and west, but east and west are also halfway between north and south, so quite obviously we have four right angles. We will be looking for right-angled triangles in our examples later so that we can use these to solve trigonometry problems. The ordinal points are halfway between the cardinal points, so the angles must all be half of 90 degrees, giving us 45 degrees in all these cases. We can continue halving for the interordinal points, and we find that all these angles are 22.5 degrees. Knowing these angles might be useful when drawing diagrams to help solve word problems. When drawing diagrams, it's not necessary to draw such a detailed compass rose like this. We usually draw the four cardinal directions represented by a cross, and we mark on north at the very least. North is often indicated by an arrow like this diagram has, but sometimes all directions are shown with arrows like this. Also, for convenience, the centre is usually labelled O for origin, if required, and the endpoint can be labelled like this P, so we can refer to the bearing of OP to mean the bearing of P from O. The bearing of PO is in the opposite direction. Obviously, it's preferable to choose letters to remind you what the point represents. L for a lighthouse, for example. Although we usually have north aligned vertically, pointing to the top of our page, it doesn't have to be done that way. However, it's easier to leave it pointing upwards. Try these quick examples. You need to draw a sketch to represent the information provided. You should include any relevant angles to clarify the direction represented. It's best to start with a basic compass rose showing just the cardinal points. We can then mark in the northeast, halfway between north and east. Hopefully you remember that the angle must be 45 degrees, but it's important to understand how to derive these angles if they're not immediately obvious. The distance travelled along the bearing is 14.2 kilometres, starting from the centre of the compass rose, because this represents the spot you are standing with your compass to face the required direction of travel. So we mark it on the diagram. In later examples, we will use the right-angled triangle from this diagram to solve a related problem. In part B, we are travelling south-southwest, which is halfway between south and southwest. We start by marking in southwest. We know that the two angles created will be 45 degrees each, but halfway between this and south is here, and the angles will now be half of 45, giving us 22.5 degrees. The distance travelled along this direction from our starting point is 10.7 kilometres. The compass rose is for basic cases only, limiting us to triangles with 45 or 22.5 degrees. There are two other more precise ways to give compass directions. They are known as compass bearings and true bearings. Both allow us to more accurately describe directions without being limited to these angles of 45 and 22.5 degrees. Let's look at compass bearings first. A compass bearing tells us the number of degrees turned from north or south, whichever the direction is closest to. In other words, the amount we turn must be an acute angle, less than 90 degrees. The bearing also tells us which direction to turn, towards either east or west. This direction has turned 55 degrees from north towards the east. The compass bearing is written like this. We read it as north 55 degrees east. Labelling the starting point O and the end point P, we would say the bearing OP, or the bearing of P from O, is north 55 degrees east. This second example is closer to south, so the bearing is south 60 degrees west. Pause the video and try these. The first is north 82 degrees west and the second is south 34 degrees west. Remember, ultimately we will be looking for right-angled triangles to help us solve a problem. Quite often we will only show the minimum information required to accurately represent the bearings, like this. These are the same for examples, although of course not to scale. Sketches only aim to give us a rough visualization. Included values always take precedence over any visualization, even when drawn to scale. Also keep in mind that we can add or subtract the relevant angles from 180 if using the north-south axis, or from 90 if also including the east-west axis. Here, 90 minus 34 is 56, giving us a choice of two right-angled triangles, here and here, when it comes time to solve a related problem. The third way we can describe a compass direction is to state the angle turned from north only, always in a clockwise direction. This is known as the true bearing, or simply as the bearing. Notice that we have the full 360 degrees marked around this compass rose. This blue arrow is currently facing due north. Its true bearing is 0, 0, 0 degrees. We state all three digits separately to avoid any possible confusion or miscommunication, so these bearings are often called three-digit bearings. 042 degrees means we have turned 42 degrees from north, always clockwise. Now we are at a bearing of 112 degrees. Then here, 198 degrees. At due west, the true bearing is 270 degrees. Next, we are facing a bearing of 314 degrees, and finally, when we reach a full turn of 360 degrees, we are back at the start, which we usually call 000, but can also be known as 360 degrees. If our reference point is true north, then the bearing is known as a true bearing. As mentioned earlier, there is a difference between true north and magnetic north, and thus there is a difference between a true bearing and a magnetic bearing. But this is not covered in most mathematics courses, and we don't expect you to take them into consideration. It's good to be aware that these differences exist, and many of you may have already discussed these in other subject areas such as geography. A true bearing should be written with a capital T after it, like these do now, just to clarify that it is indeed a true bearing being described. We can represent our bearing with simplified diagrams, but we might need some basic calculations with the provided angle to determine the full angle turned clockwise from north. The first one simply needs a 0 inserted to make it a 3-digit bearing, giving us 055 degrees. In the second, we see that we have gone 34 degrees past south. Knowing south is half a turn from north tells us it's equivalent to 180 degrees, so adding the 34 degrees gives us a bearing of 214 degrees. In the next one, we are 60 degrees before south, so we need to subtract 60 from 180, telling us that this bearing is 120 degrees. And the final one shows that we are 82 degrees west of north. In other words, we are 82 degrees short of a full revolution. Subtracting 82 from 360, we get a bearing of 278 degrees. Pause the video if you'd like to try these examples. The first one is straightforward, since we see that the angle turned is 135 degrees, giving us the bearing of 135 degrees. In the second, we need this angle, but we know this one is 20 degrees instead. Subtracting from 180 gives us a bearing of 160 degrees. We could also have found this to be 70 degrees and added this to the 90 to achieve the same result. The next one has the same 20 degrees but towards the west instead of the east. So adding it to 180, we find that the bearing is 200 degrees. The final example is in fact due west, but we are asked to find the bearing. We could subtract this 90 from 360, or we could add 3 lots of 90 moving clockwise from north. Either way, the bearing of due west is 270 degrees. If it was further past west, like this, we would either add the amount to 270 or subtract this amount from 360. The bearing is 300 degrees. Be sure to watch the next video in the series to see how to apply these skills to solve simple word problems.